Well, to our fellow Americans, brave warriors, and steadfast allies, one message was made unmistakably clear from the very beginning. We said it would not be a fair fight, and it has not been. The United States is decimating the radical Iranian regime's military in a way the world has never seen before. Tonight, Iran's navy is gone. Their air force lies in ruins. Their leaders, most of them, and the terrorist regime they led, are now dead. And yet, in the middle of that overwhelming destruction, one of the strangest military contradictions of this war has emerged. The United States Air Force has been trying to retire the Aten Thunderbolt II for more than a decade. The case has been made again and again, and on paper, it is a strong one. The aircraft is slow. Its radar cross-section is enormous. Its systems are decades old. In contested airspace filled with modern surface-to-air missiles, its survivability is limited. The F-35 Lightning II can do most of what the Aten does, but faster, with better sensors, and with stealth characteristics the Aten will never have. Those arguments have appeared repeatedly in budget documents, capability assessments, and congressional testimony. But then the order came. Deploy 30 Aten aircraft to the Strait of Hormuz. Not because the Air Force suddenly changed its mind about the aircraft's weaknesses, not because the retirement arguments were wrong, but because the Strait of Hormuz exposed a problem that none of the aircraft meant to replace the Aten could actually solve. At any given moment, the Strait of Hormuz contains more than 3,000 civilian vessels, fishing boats, cargo ships, tankers, small passenger ferries, traditional dhows that have been moving goods between the Gulf states and the Iranian coast for centuries. This is not a clean tactical environment. It is not a battlefield where military targets sit neatly separated from civilian traffic in open water. It is one of the most congested maritime corridors on Earth, packed, crowded, chaotic. And that is exactly why it matters. Iranian fast attack boats do not operate in empty seas where they can be picked out at a glance. They move inside that civilian traffic deliberately. They weave among fishing boats and cargo vessels. They use radar clutter. They use visual confusion. They use the legal presence of innocent maritime traffic as camouflage to complicate identification and targeting for every force operating above them. The problem is not finding boats. The problem is distinguishing the threat from everything else in the same water, at the same time. Now, on paper, the F-35 should dominate a problem like this. Its sensor systems are the most capable airborne target identification technology ever fielded. Its electro-optical targeting pod can resolve surface targets at ranges that would have been considered impossible a generation ago. Its synthetic aperture radar can build detailed ground and surface pictures regardless of weather or time of day. Its data fusion system integrates inputs from every onboard sensor and from other platforms across the network into a single, coherent tactical picture. It can see more, at greater range, with more precision than any aircraft in history. But the harsh truth is this: seeing more is not the same as understanding more. Looking down from altitude at combat airspeed over 3,000 vessels, the F-35 sees heat signatures. It sees radar returns. It sees objects moving across the water at different speeds and on different headings. But it does not automatically see the difference between a fisherman pulling nets and a fast attack boat crew preparing a weapon for launch. That difference, in the real world, is not always a matter of sensor resolution. It is a matter of context, and context takes time. The physics are brutally simple. Angular velocity, the rate at which a target moves across a pilot's field of view, increases directly with aircraft speed. An aircraft flying at 500 knots covers a nautical mile in approximately 7 seconds. At that speed, the time available to observe, process, and classify a surface target below is measured in fractions of a second per target. Yes, the sensor systems can record faster than a human eye can track. Yes, the computers can process data faster than a human brain can sort it. But processing speed is not the same as contextual understanding. A sensor records what is there. A human observer understands what it means. At 450 knots, a boat is a heat signature and a radar return. At 220 knots, the Aten's typical combat airspeed over a target area. A boat becomes a boat. The pilot can see the hull shape, the engine configuration, whether there are nets hanging over the side or weapons mounted on the deck, whether the men visible on board are dressed like fishermen or like military personnel. whether the vessel's heading and speed match its apparent purpose, or whether something about it feels wrong. And that is the heart of the entire issue. This is the dwell time advantage. Not a sensor advantage, not a processing advantage, a time advantage. The Aten spends more time looking at each target than any faster aircraft can. And that extra time is what makes classification possible. The MQ-9 Reaper appears, at first glance, to offer a solution. It flies slowly, with a cruise speed of approximately 200 knots, which gives it the dwell time the F-35 lacks. Its sensor suite is capable. Its endurance over a target area is measured in hours rather than minutes. In a permissive environment, against a static or predictable target, the MQ-9 is an effective system. But the Strait of Hormuz is not that kind of environment. The communications link between the MQ-9 and its ground control station introduces latency, a delay. Sometimes fractions of a second, sometimes several seconds, depending on the communications architecture in use. And in an environment where a fast attack boat can close distance to a target in seconds, that delay is not some minor inconvenience buried in a technical briefing. It is the difference between an interdiction that succeeds and one that arrives too late. Artificial intelligence targeting systems run into a different version of the same wall. In controlled testing environments, with defined target sets and clear background conditions, AI classification systems can perform with impressive accuracy. But the Strait of Hormuz is not controlled. The background is not clean. The target set is not neatly defined. The algorithm trained to identify fast attack boat signatures suddenly confronts 3,000 vessels with overlapping signatures, variable lighting conditions, sea clutter changing with wave state and wind, and Iranian operators who understand exactly what the system is looking for and are actively trying to defeat it by mimicking civilian vessel signatures. The AI sees what it was trained to see. It has no framework for what it was not trained to see. A veteran Aten pilot does. That pilot has spent a career learning to recognize the things that do not fit, the boat that moves wrong, the vessel whose configuration does not match its apparent purpose, the heading that makes no sense for a fishing run, the speed profile that feels inconsistent with civilian behavior. The F-35 pilot is not failing because of a lack of effort, or a lack of training, or a lack of technology. The aircraft itself creates the limitation. Its speed imposes a physical constraint that no amount of training can erase. A target that flashes through the pilot's field of view in less than a second cannot be meaningfully classified, no matter how experienced the observer may be. That is not a human limitation. It is a physics limitation. The A-10 does not solve that problem by having more advanced sensors. It solves that problem by flying slowly enough that the physics become manageable for a trained human observer. In a very real sense, the aircraft is not just a weapons platform. It is a platform designed to place a human brain in exactly the right place, at exactly the right speed, for exactly the right amount of time, to do something no current automated system can reliably replicate in this environment. That is why it came back. Not because the retirement case vanished. Not because the Air Force suddenly forgot every weakness the aircraft has. But because when the crowded waters of the Strait of Hormuz turned identification into the decisive problem, the old aircraft that was supposed to be on its way out became the one machine still capable of solving it. The Aten pilot, working a maritime patrol mission over the Strait of Hormuz, does not rely on magic, does not rely on some mythical instinct. What happens in that cockpit is disciplined, repeatable, and brutally practical. A four-step process is run on every surface contact that warrants attention, and really this process is exactly why the aircraft is still there. First, scan. The initial acquisition of the contact. Its position, its speed, its heading relative to the surrounding traffic. A first look, fast but deliberate. Then, contextualize. And this is where the difference begins to open up. Is its speed consistent with the vessels around it? Is its heading consistent with the traffic flow in that part of the strait? Is it moving toward the shipping lanes or away from them? Is there anything in its behavior that does not line up with what a legitimate civilian vessel should be doing at that location, at that time? Really, this is the moment where raw sight becomes judgment. Then classify. Combine the visual observation with the contextual assessment and make a preliminary determination about what the contact is and what it is doing. Not just what it looks like, but what it means. And finally, decide. Translate that classification into action. Continue observing, request additional information, pass the contact to another asset, or engage. That entire sequence, scan, contextualize, classify, decide, takes between 15 and 45 seconds for a trained ATEN pilot working a contact that warrants close attention. For a contact that is clearly civilian, the scan phase is often enough, and the process may take only 2 to 3 seconds. But for a contact presenting ambiguous indicators, the pilot may run multiple orbit passes, accumulating observation time across several minutes before reaching a classification decision. And that is the point, not the speed of the computer, not the sharpness of the screen. Time over target, time to look again, time to notice the one thing that does not belong. This process cannot be replicated by a sensor system operating at 500 knots. It cannot be replicated by a remotely piloted aircraft with communications latency of several seconds. It can only be replicated by a trained observer with enough dwell time to run the full sequence. And that means an aircraft slow enough to provide that time over the target. This is why the contradiction at the center of the ATEN story becomes so uncomfortable for the Air Force. Its institutional position has not changed. The aircraft is survivable only in permissive or semi-permissive airspace. Its maintenance requirements are significant. Its operating costs, while lower than the F-35 on a per-flight hour basis, still represent a continuing investment in a platform whose long-term future in the inventory has been questioned for years. Every argument for retirement that was valid before Operation Epic Fury remains valid now. But 30 ATEN aircraft are currently operating over the Strait of Hormuz because the replacement capability that was supposed to make those arguments irrelevant does not yet exist in a form that can solve the maritime identification problem in a congested civilian environment. That contradiction is not hidden. It is visible in the deployment itself. An aircraft the Air Force is retiring has been sent into one of the most operationally demanding environments in the current conflict. The crews flying those aircraft understand exactly how strange that is. They have been told the platform has no future, yet they are flying it in a mission that no other platform currently in the inventory can perform as effectively. That gap, the gap between what the retirement schedule says should already be possible and what the operational environment actually demands, is being bridged the same way it has been bridged in every conflict since 1991. By the aircraft that budget documents keep scheduling for retirement, and by the operational commanders who keep finding reasons to keep flying it. Then comes the second punch. Not just effectiveness, but cost. The GAU-8 Avenger cannon mounted in the nose of the ATEN fires 30mm rounds at 65 rounds per second. At a unit cost of approximately $137 per round, it remains one of the most cost-effective weapons in the Air Force inventory for engaging small surface targets. A single ATEN sortie over the strait can identify, classify, and engage multiple Iranian fast attack boats in a single pass at a cost per engagement that is only a fraction of what would be spent using a Hellfire missile from an MQ-9 or a small diameter bomb from an F-35. And in a conflict like this, that matters more than many people want to admit. In an environment where engagement costs and weapons expenditure rates are operational constraints, not side notes, the ATEN's ability to deliver effective firepower at low cost per engagement is not some secondary advantage. It is part of the capability itself. The economics strengthen the operational argument. They do not replace it, but they make it even harder to dismiss. So, the 30 ATEN aircraft over the Strait of Hormuz are not there because the Air Force reversed its judgment on the platform's weaknesses. They are there because the battlefield exposed a capability gap that retirement would turn into a permanent wound. The aircraft designed in the 1960s to kill Soviet tanks in the Fulda Gap is now flying maritime identification and interdiction missions over one of the most crowded shipping corridors on Earth for one simple reason. It is still the only platform in the inventory that flies slowly enough, long enough, with a pilot skilled enough to tell a fishing boat from a fast attack boat inside 3,000 vessels of mixed traffic. And that capability, the trained human eye with enough dwell time to make a classification decision in a chaotic environment, is exactly what no sensor system, no artificial intelligence algorithm, and no remotely piloted aircraft has yet replicated under the conditions that actually exist over the strait. That is not nostalgia. That is not sentiment. That is not resistance to modernization. That is operational reality. The retirement schedule will resume when this conflict ends. The budget arguments will return. The capability assessments will reach the same conclusions they always have. The Aten is not stealthy. It is not modern by the standards of current procurement logic. It is not the aircraft the Air Force wants to build its future around. All of that remains true. But the next time a congested maritime environment demands a slow aircraft, a trained pilot, and enough time over the target to tell the difference between a real threat and a civilian vessel, one question will matter more than any line in any budget document. Does that capability still exist in the inventory? Because that is the real lesson of the Strait of Hormuz. The Aten is not irreplaceable because it is the best aircraft. It is irreplaceable because the specific combination of speed, endurance, weapons load, and pilot dwell time it provides has not been replicated by anything built to replace it. That is the contradiction no one can hide from. The platform everybody keeps trying to retire is still the one commanders reach for when the environment becomes too crowded, too ambiguous, and too dangerous for cleaner theories of air power to survive contact with reality. And really, that is what makes this story so striking. This is an aircraft born in the 1960s, built for a completely different war, designed to kill Soviet tanks in the Fulda Gap. Yet, here it is, flying over one of the world's most congested shipping corridors, running maritime identification and interdiction missions, because the future that was supposed to replace it still cannot fully do what it does. Not here, not in this environment, not under these conditions. That is not an accident. That is not a fluke. That is the battlefield delivering a verdict. The trained human eye still matters. The slow orbit still matters. The ability to watch, doubt, confirm, and only then strike still matters. Because a sensor can record, an algorithm can classify, a network can fuse data. But when 3,000 vessels are moving through the same water, when civilian traffic and hostile intent are deliberately mixed together, when a mistake is not just a missed target but a disaster with strategic consequences, then really, the final margin of judgment still belongs to the human being who has enough time to see what is actually happening. That is what the Aten provides. It does not solve every problem. It does not survive every battle space. It does not invalidate the case for modernization. But in the Strait of Hormuz, it solves the problem that mattered most. It gives a trained pilot the time to scan, contextualize, classify, and decide before a target disappears back into the clutter. It gives commanders an interdiction platform that can identify and engage multiple fast attack boats at a cost that remains operationally sustainable. And it gives the United States a capability that, despite years of planned retirement, still has no true replacement in this specific mission set. That is why the Warthog flies. Not because it is perfect, not because it is new, not because the Air Force stopped wanting to retire it. It flies because the battlefield forced a confession from modern air power. The system that was supposed to make the Aten obsolete has not yet arrived in a form that can solve this problem. Until it does, the old aircraft remains alive, not in theory, not in nostalgia, but in combat. And that may be the most important truth of all. Wars have a way of exposing the difference between what institutions plan for and what reality demands. The Strait of Hormuz did exactly that. It revealed that in one of the most operationally complex environments in the current conflict, the aircraft everyone thought was living on borrowed time is still the one that can do the job. Until something else can match that combination of speed, endurance, weapons load, and pilot dwell time, the question will remain open. And every time that question returns, the answer will sound the same. Until it is truly replaced, the Warthog flies. If you enjoyed this story, feel free to leave a comment, drop a like, and subscribe in your own time for more deep military analysis like this.